Hello, 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 hello. Hello, hello. Hello, hello, hello. Hello, hello, hello. Hello, hello, hello. 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 Hello everyone. Yeah, it's live and we can start. Almost we have 25 people and we are also live on YouTube. So guys, who is watching on YouTube, please join. Let me share my the Zoom link so that you can directly join to the Zoom. Can one second. Let me share in the chat. Ah, yeah. This is the Zoom link where you can use join online classes for this session only. Every time it will be new. Let's wait one more minute and let me set up something else. So we are live everywhere. Okay, so let's start today's class about CCNA and five. We basically for a 5 day workshop. One second. I'm starting now. Okay, so welcome guys. Welcome to Networking Scholar, and we are starting today's CCNA free webinar for basic thing and as well as advanced. So today we will discuss few topics like what is architecture, what is OSI model, what is TCP/IP. If there will be some time to take some extra time with you guys, then we will go forward. So let me introduce myself. My name is Ramesh Kumar Sharma, and I have 7+ of year of experience in network and network security. So I will be the instructor for your entire course of CCNA to 200 and 301 in Hindi and as well as in English. Okay. So if you have any question, you can just chat or we will give you the answer. So it will not disturb anyone. Okay. So let me start with the very first thing, which is network related thing. So first we will discuss about what is networking like that. So let me start that, guys. Hope screen is visible to everyone, right? You can chat. You can see the chat, so I can see. Let me enable chat as well. Jump to the Radhesham, we will cover as soon as possible in Hindi, or this will be in the bilingual, so no worry. आपको सब कुछ समझ में आएंगी. So let me start first today's. So basically everyone is connected through a network, right? Like we are using Zoom. So we need to understand what is Zoom and what is networking. So Zoom, there is not need to learn about Zoom today. So we are going to learn about networking, computer networking. So basically what is computer networking? Okay. So computer networking is what? A computer is collection of interconnected devices, systems, and that communicate with each other and share resources and information. Like we have connected through a phone or internet, like we are using Zoom for this session. Someone is watching a YouTube. If needed, we will go for it. Okay. So everything is related with device or and system. Someone is using to use this kind of application. What we are using here, mobile or PC. PC in the sense personal computer, that could be a laptop or workstation as well. So we are using this thing. Okay. So for example, one second, one second, guys. So, and that what kind of devices we are going to use? I think recording wasn't started, so it is just started. Okay, so it's started again. So what kind of device we are going to use? In the computer network, we are going to use like computer, server, printer, router, switches, and other hardware like firewall, access point. Okay, and there will be many more devices which can use in networking. Okay, so apart from it, there are many things as well. Like each devices have unique identity and identifiers such as MAC address, media access control. We will learn here about the MAC addresses, how it is going to work, and IP addresses as well. So every system has their specific IP addresses. Let me go with. Let me show you the how we are going to check the IP address of the devices and MAC address as well. So this is my computer window, okay, or I have opened CMD and I am going to type ipconfig. Okay, if I'm going to use ipconfig, I am able to see my IP addresses and DNS as well as default gateway. If we are going to use ipconfig/all, if you will use, then we will get all kind of information about the IP addresses as well as MAC address. Here you can see this is the IP address. This is the MAC address, which is called physical address in computer Windows machine. Okay, so this kind of information which is required to connect between device to device. Then there is connection medium. How they are going to connect? They are going to connect with the using wired or wireless. As I shown you, this is my wired network. Okay, Ethernet adapter. Here you can also see there will be a wireless as well. So this is connected through a wireless, and we can use both of the uh, communication medium. Either it could be a wire or wireless as well. Wireless network, we are using radio wave signal, like phones are connected, or you have in your home network there is a Wi-Fi, and it is you are connected to that Wi-Fi. So this is kind of that. And then there is something called protocol. Protocol is also important part of computer networking. Why it is important? Because suppose that if you are watching YouTube, then you are using a web browser or application. So it is working through a protocol. Either it could be a HTTP or HTTPS. Okay. So there are some kind of protocol we will use, that is DCP and UDP. In later we will discuss about this thing in upcoming next video or next set slides. Okay. Then we are going to discuss about topology, how we are connected. You hope you guys understand the last thing. So topology is how the devices are connected to each other. Okay, like computers are connected, how it is connected in a network, how it is connected in a home network, how it will connect in the corporate network or data center, or we can say that ISP service provider side. So we will discuss like that. So there are few type of topology we will learn here. That first we are going to learn about star topology. What is star topology? And star topology, every device is connected through a central hub or switch. Okay, all all data transmission is passing through a central hub. Everything will be in there will be a device in middle, and that every device will be connected through that. Let me show the example to you. So this is the central hub. Okay, we can say that it is hub or switch. This kind of device. So here you can see there are four PC are connected, A, B, C, and D. Okay, four devices are connected. So it's look like a star. Here you can see. Okay, I forgot to mention a host, so you can use this one. So it's look like a star. We are making a star. How? Suppose that we are making a star like this, or we can make like this. This is also called a star gear button as well. Okay, so this is kind of the thing. And we are going for bus topology. Let me stop it. Sometime it is causing an issue. Let me go with bus topology first. So this is bus topology and how it is going to work. Suppose that we are sitting in a bus and we are traveling through a bus from source to destination. Then how devices will be connected? It will connect look like. Here you can see there are four hosts, and this is the single cable, every cable is connected through one cable and one host. So here you can see this is the seat number 1, 2, we can say that 3 or 4. So we can use like this. Okay, so this is this topology called bus topology. So here you can see if the bus topology, all devices connected to a single cable called bus. Okay, data transmission along with the bus, each device can receive data by one only the intended recipient process it is. Then we are going to learn about topology, that is ring topology. I don't know what is happening with it. Let me 1 second, guys. It is heavy, that's why it is taking time. And then we are going for ring topology. So ring topology, every device should connected through in a ring circle. Like there will be a circle and every device is connected to each other. This is costly because every device should have at least there should have two Ethernet card or two LAN card to connect each other. Suppose that this is host A, right? This is host A and this is B. There is required two LAN card to connect to make a ring topology. Here you can see this is connected through one A between A to B. You can see, and this is D, C, D, E, F, G, H. So here you can see A is connected through H as well as B. So there is required two LAN card to connect each other. Yes, Mohammed. Mudassir. 1 second. Okay, so we are going for next now. We have mesh topology. So what is mesh topology? Everything is connected in a look like every topology should be here, like ring, bus, star, and other. Okay, we can as well as you can see mesh topology. It's wrong maybe. Mesh topology, every device is connected to everyone. So it's look like, suppose that there is a PC1, PC2, PC3, and PC4 we have. It is connected through all PC are connected to each other. This is fully mesh. Suppose that one cable got broken, then communication is not going to be stopped here because it will connect it will pass network from this way or this way. Suppose that or this way as well. It is going to pass look like that. So everything is connected in a fully mesh. There is not any kind of issue it will create in further. Okay, then there is tree topology as well. I don't know what is happening with it. Then we are going to learn about tree topology. So what is tree topology? Tree topology is like that. We have seen a tree. This is a kind of tree, right? There is a multiple branches and there is sub branches over there in a tree, you can see. So this is also similar like that. Okay, stop it. So here you can see this is the tree topology. Maybe my pen is getting tapped, that's why it is what it causing an issue. So here you can see this is the star topology. There is a bus topology, star topology, bus topology, mesh topology. So there will be sub branches. So this kind of topology called tree topology. So tree topology is a combination of star and bus topology, we can say it. Okay, star and bus topology. Devices are arranged in hierarchical with multiple level hub or switches. There will be multiple hub and switches connected between devices. So then next is services. What kind of services computer network is going to be used? That network provider services multiple, there are multiple services. Okay, network, like it will we can use file sharing. So suppose that you have to share a file to me or I have to share file to you. So in that case we are going to use file sharing. Like it will allow to store and create, store any file, there is a any file in your drive and you want to share with your user, then you can use file sharing. Then there is print sharing. Suppose that there is a printer, only one printer in your network or computer network. If you want to use that printer from if you want to use that printer for every user, then you can also do this by sharing printer. Okay. And there is internet access. Internet access is what, when we are suppose that we have only one router and we want to and there is 10 or more than 10 users in the network, and they are trying to go what, they are trying to go use internet. In that case, what we can do, we can, it can share by internet as well. Then there is email email exchange is also possible through in computer network as well, because you seen we have sent multiple emails today. So this kind of thing is possible through a computer network. Then there is remote access. Remote access, suppose that if someone is trying to take any kind of remote like SSH, Telnet, RDP, so we can take remote from by using computer network, either by using VPN or any kind of remote desktop protocol, either like AnyDesk or something else. Okay. AnyDesk, RDP, there is a Google screen sharing, like look like that. Then there is something called security in the computer network. So network security is essential, protect against unauthorized access. Suppose that someone is trying to gain access of your computer or network devices. In that case, we can use security as well in a computer network. Then to prevent what kind of devices it is including security. So there is a firewall. Firewall is what it is doing, filter incoming and outgoing traffic, outgoing network traffic to block an unauthorized access. Suppose that someone is trying to gain access of this computer, like this computer in the sense one my PC. So what it will do, it will prevent my network by using uh, by taking their username and password in their database. If it is exist, then allow. If policy is configured for that, then it is allow, otherwise it will not allow to anyone. Okay. Then there is encryption. Some kind of encryption will happen during starting communication by maybe suppose that one user is trying to gain access of your computer. If it is not encrypted, or this is they are using, you are using password, if the password is not matching, in that case it will not going to be authenticated. Then there is access control, the third point. What is access control? Access control is that if the user is allowed or denied. Suppose that we have two types of user. One user is the guest user and one user is our internal user. Suppose that internal user want to access, then we have created a policy. Suppose that internal user is coming from let me draw on. So this is your internal user. Okay. And there is a firewall and it is trying to hit, this is your file server. Okay. And it is trying to use authenticate or access this server. Internal user are allowed, and there is also a guest user, and guest user is in your different subnet or different network, and it is not allowed. Then firewall, what it will do, it will check the access policy, access ACL, access control policy, and it will deny. Okay. Then there is next thing, one second, IPS and IDS. Again, it's happening. Then there is IPS and IDS. Let me erase. So IPS IDS, what it will do, it will do, suppose that someone is trying to get access of unauthorized website, like someone is watching pornography or something else, and your company domain administrator or company firewall administrator or security administrator is denied that particular policy for using unauthorized website. Then it could be a possible by using IPS or IDS. Suppose that something is coming from outside, and that is trying to that is trying to hack, or maybe trying to be look like an attack. So it can prevented by IPS or IDS. So IPS is the prevention system, or DS is detection system. So detection, IDS will get IDS will do like some, it will send notification, or IPS will prevent your network. Okay, so this was the first part which we covered, and then we are going to going for a next session that will be our devices, related with devices. Okay, so yeah, what was your question? You can unmute yourself and you can ask. Okay, no issue. I don't know. So now we are going for our next topic, that is our encryption decryption of OSI model. So OSI model we are going to learn why, because this is an important model, important architecture based model, because it is, everyone is going to use this. Okay, so let's go. What is OSI model? First, we will learn about it. So, what is OSI model? OSI model is open system interconnection model. That this is a concept. Okay, suppose that you are going for a job and you will see what there is a some kind of level. Okay, there is a some kind of label in your network like L1, L2, L3, L4, L5. Okay, so this is similar, like similar look like that. We will see here there will be 7 layers, and we will learn for each layer by using encapsulation, and after that we will learn about the encapsulation as well, so that how packet is going to be encrypted, or how packets are going to use in a network. Okay, so then origin. So it was started in 1970, late 1970, because some by using who IOS. Oh, sorry, International Standardization Organization, ISO. It's called. Started working on it, and it's created a protocol that is a framework that is called OSI layer. This the first thing is that when we will learn about OSI model, we need to understand each layer of network OSI model, because it is that much important, that like till then we are not going to understand OSI model, we are not going to understand about network, computer network, either it is security based thing or other thing. Okay, then developed when it's got developed, it's developed by IEEE. It IEEE, here is this, you can see the full form of IEEE, Institute of Electronics and Electrical Engineer. One second guys, let me take water first. So you are not allowed to unmute. So how it's started development? Okay, so it was started by using multiple by using collaboration, like someone is trying to do some work, some specific term look like that. So there was some organization was include like ISO, as well as UITU, International Telecommunication Union, and IEEE. Every organization have worked on this, and after that OSI model created. Okay, so what was the goal? Let me go with the goal. So what was the goal? The goal was to create a comprehensive model that could accommodate a wide range of networking technology and facilitate communication between devices, drives system. Oh, sorry, diverse system. Okay, hope you understand. And then what is OSI model? Again, we are talking about. So OSI model when it was published. So OSI model was published in 1984, and this is standard. So if you are going to search about 7498, then you will see the OSI standard, which is a white paper published on 1984. Okay. Then there is TCP IP. So after that TCP IP, OSI model was just just a overview. Not we are not using OSI model. We are using TCP IP in current domain. So instead of the TCP IP, transmission control protocol and internet protocol suite emerged in the domain networking architecture during 1980s. Okay, and 1990s. Between 1980s and 1990, TCP/IP domain come in market primarily due to its early adoption by ARPANET. It's good. It's get applied everywhere because it was adopted by ARPANET. ARPANET is a internet that organization which is maintaining IP addresses and IP addresses based related thing like internet related thing. Okay, so legacy and influence all through the OSI model was not widely implemented in the network protocols. Why? Because there was 7 layer of architecture, and it is because of that it was big to understand. It is remainly highly influential as a conceptual framework because it was just a concept we are not going to use. Okay, then there is a 7 layer. What kind of 7 layer is there? So we are going to learn about it. Okay, so 7 layer is what? First is we have application presentation session. So we will learn for each layer. So first layer is a physical layer, and physical layer, then there is a other layer that is called data link layer. Then third layer is network, fourth layer is transport, fifth layer is our session layer, sixth layer is presentation layer, and seventh layer is application layer. So here you can see the picture of all of the layers. So what kind of devices, what kind of protocol, and what kind of the thing which is going to be used in a layer OSI model. So we will learn here as well as. Okay, so here you can see this is layer first, that is physical, then second data link, then third is network, fourth is transport, fifth is session, sixth is presentation, and seventh is application. So application is basically user interface. Apart from it, we can see only first layer 1 and layer C. Between these, there are 5 layers. We can see this by using eyes. Okay, then we are going to learn about first layer 7 because we are going to use encapsulation as well. So layer 7, it's provide interface for application level services and protocol, enabling end user application to access network resources and services. Like how, suppose we are someone is using Zoom and someone is using other application, like someone is using our mobile application, or someone is using browser as well. So in that case, it is allowing different user to use, and we can see the application. That is called what application? Either it is Chrome or browser. So there are some functions of it. Like there is a function application layer provide network services directly to the user. Network services directly to the user or user application. Like you can see the message, you can see the video, you can see the music, sorry, you can see the videos as well, you can see the file document, anything. It's allow application to access network resources and to communicate with other applications. Like someone is trying to access some web based application, then we can also use by using application layer. Then there is encapsulation as well. Application in the application layer, when the user is trying to gain some access, like at a layer from application layer, it is prepared for transmission. For example, someone is trying to get a waves, they are using web browser and it is trying to reach any website. Then what it will use? It will use HTTP protocol, and that is only possible through a browser, and browser is work on application layer. For example, suppose that we will take some example like HTTP, SMTP, HTTPS, file transfer protocol. So we are using like that. Okay. The user create an email. For example, suppose that if you're talking about example and SMTP, so user will create a email using email client application, right? Either Outlook or Gmail application. The application layer adds email header to the message. Application layer, what it will do, it will add header message header, okay, and include information such as sender and recipient, who is senders, who is recipients, and subject. And there is also one thing what it has created emails. There could be a message as well. So it will send. Suppose that this FTP client and it's trying to gain access of FTP server that is trying to copy something. So what it will do, it will create session, it will open application, and we will use application server. And what we will ask, suppose that we are using we will access directly the FTP server and we can copy the thing. Okay. Then there is the next layer is presentation layer. So presentation is that, suppose that we are using a file, or we are using like docs, Excel file, PowerPoint presentation. In that case, we are going to use this thing. Okay. So suppose that uh, user is gaining access of a video from their file server. Then it will, how it will come, it will come from layer 1, layer 7 to layer 1, and layer 1 to layer 7. Then there could be a function, right? How it is going to work, the presentation layer translate data from application layer format into the standard format from transmission over the network. It's handle in data encryption, compression, and formatting. Like suppose that some there is a format like docs, or we can say that as well, docs is there, mp4, mp3, excel, .xls, or there are many more type of extension is there, format is there. So by using this kind of function, it will create some header. Okay. Then it will encapsulate data from data. So sorry, data from the application. It is formatted and encoded into a standard recipient suitable for transmission. For example, HTTP request may be encrypted using SSL or TLS before transmission. Like if you are using any kind of website in today's network, so there you can see this is protected or not protected. So it is presenting like that. So that is protected through TLS, transport layer security, or by using SSL. Okay. Then there is, let us go with the example. So secured socket layer or transport layer security. For encryption, we are using JPG image for encryption. Presentation layer. Okay. There is a suppose that let I will explain in later when we are going to when we will go for we will capture the packet in upcoming videos. Okay. So, and what is the presentation layer? Presentation example of other example is the presentation layer may perform tasks such as encoding the message and ASCII or Unicode format. Okay. It's add on header or modify the data format it's needed. Suppose that the data from application layer, it is extracted and manipulated in the required format it for transmission. Suppose that mp3, mp4, docs as well. And then there is next session, that is next layer, that is session layer on layer 5. Suppose that we have established a session between source to destination. Source PC is trying to send information to destination PC. A wants to communicate B. Then there should be a session between these devices. So session layer work on that layer to build a session between A and B. Okay. So here you can see the session layer is establish, maintain, and terminate communication between applications. Like suppose that we are using web browser and we are watching something on that browser. In that case, their session layer, what it will do, it will create session between your browser, that particular session, particular tab, and with the server where it is existing, where it is located. and it will, what it will do, it will maintain as well that session, because suppose that if someone is you, if you want to reload, or you are continuously watching, then it will maintain your session. If you will you don't want to watch that particular videos or something, then in that case it will terminate that session as well. Then how it is going to be encapsulate, it will encapsulate like such kind of there it will use protocol, some protocol, or we can say that terminology. The session layer provides services such as session establishment, synchronization of the layer above layer. It will synchronize between, say, 6 layer and between layer 4. Okay, it doesn't perform encapsulation in the, because who is going to be perform encapsulation, that is or based on presentation layer is going to be do that thing. Okay, and there is a, let's go with the example. There is a net bios. Net bios is network basic input output system, and RCP, remote procedure call. So it is, this is just an example. Suppose that the session layer is established and manage and terminate the session between email client and email server. Suppose that someone is using some browser or browser based or client, then it session layer will establish communication between server and client. Okay, and it is added on layer, it will add its own layer that contains session information, like how it is going to be used. Then there is fourth layer, that is transport layer. Transport layer is it is important layer, as we will learn when we are going to, we will configure the router. So basically on the layer 3 layer 4 basically, okay, router or firewall. So it is ensure what transport data is, ensure reliability and data between delivery of data, source and destination node, handle issues such as data segmentation, flow control, and error recovery. Suppose that you are sending some file from source to destination, and so in between there will something happen, that in that case transport layer is responsible to make to send data from source to destination, or you are, if you are copying data from server, then transport layer is responsible for that. Suppose that if you are watching a video and sometime it is getting buffered, so transport layer is only responsible for that. Okay, so how it is going to be function, if transport layer ensure that reliable and it's what it will ensure, because this is reliable and it is deliver the packets orderly. Suppose that someone if you have a packet and you have separated this packet into multiple segment, so it will mention a segment and it can transfer look like that. Okay, it is provide end-to-end error recovery. Suppose that something happen between your transmission or between sending or receiving info data, so it will recover, it will mention the number on every packet. So whenever the packet is getting received by the user or sent by the user or application, it will acknowledge every time. Okay, segmentation as well as what is encapsulation. So how it is going to encapsulate, data comes from upper layer, that is fifth layer. When it will come from fifth layer, it is segmented into a smaller unit. Okay, so it will segment and assign sequence number for reassembly. When, let me draw it, this is user and it is sending a file. Okay, it is sending a file to PCB. This is A and this is B, and there is 1 MB file, right? It's segmented into 4 part, 20 almost 1 MB, suppose that 100 MB. So 25 MB, it is using four, it's converted into 4 packet. Just an example, okay, just an example. So it's convert on 4 packet. So what it will do, it will mark a sequence number on every packet, so that when the all packet will go to the destination, it will check what, it will check number and reassemble the packet by sequence 1 2 3 4, so that suppose that we are using HELLO, and it was sending H is to 1, E 2, LLO 3 4 5. Suppose that something is missing, then it will check and it will also again ask to it will check and it will recreate the it will check the thing. Suppose that one L is missing, then it will check, okay, L is missing, so it will reinitiate and it will check for the packet. If the packet is missing, then it will discard. If till then packet is available to the source or center, it will collect that packet and it will reassemble the packet. Okay, and then there is again happen same thing. How it's going to 1 second, guys. I don't know what is happening with that. 1 second. There is some issue with the PowerPoint, I think. Yes, Ahmed. Are you there? Okay, no issue. So we were on transport layer, right? So we already see how it is going to be performed. Let me share my screen again. Maybe there is issue with something. So it will what it is going to be used. It will use TCP and UDP. So we will learn later TCP IP model. So transmission control protocol or internet, but there is TCP and UDP, transmission control protocol as user datagram protocol. So it will ensure that you are using that communication medium. Either it is datagram protocol or TCP. So TCP is reliable and UDP is non-reliable. Okay, so it will check for that. Then transport layers, what transport layer security? It will suppose that it segmented a similar chunk. It will segregate. It will what it is going to be do. It is going to be segment the traffic in small chunks. If 1 second, maybe there is issue with my something is there missing. 1 second, let me disconnect it. Okay, maybe there is issue with my keyboard or something. It will segment into small chunk if necessary to facilitate reliable transmission, because suppose that something will be missing, then packet will be discarded. It will add on header including source and destination port number, sequence number, and error checking information. We will discuss in deep when we will capture the packet in upcoming videos. Okay, then there is layer 3, that is network layer. Network layer works for what? Network layer is responsible to share information from source to destination. Like, what is the function of network layer? The network layer is responsible for routing packet from source to destination across multiple network. It's handle logical addressing, routing, and fragmentation. Okay, and reassembly of data packet as well. Encapsulation. What is encapsulation? Encapsulation is how it is going to be encapsulate data packet from transport layer. It is encapsulated into a packets. So we will learn about packet. Each packets contains source and destination IP addresses. For example, we are taking an example. Suppose that this is 192.168.1.1, and it is there is a router, and there is a PC, also a PC. The IP address is 192.168.1.2.1. If it is trying to be trying to communicate with different networks, so in that case, network layer is responsible to make this communication happen between two different network. Okay, then what is internet protocol here? And we will use internet protocol as well as, one second, uh, internet protocol, and we can just for example, or ICMP, internet control messaging protocol. Okay, let me erase. And then there is other layer in the network that is called data link layer. Data link layer is what? Data link layer is basically between it will work between layer 3 and layer 2 based on layer 2. That's why we are layer 3 and layer 1. Because of that, why? Because we are using here MAC address, and MAC address is layer 2 thing. Okay, so manage the transmission from data frame between adjacent network nodes, providing error detection and correction mechanism. Function, what is the function of the layer 2? Layer 2 provide error free transmission of data between adjacencies node over the physical layer. Suppose that physical layer, it's handle framing, error detection and flow control. It's handle three things at least. Okay, framing, it will handle framing, because we learned what on layer 3, there was data packets. So packet will convert into frame, and then it will check error detection, it will check error there is anything missing in between, or it will also help in flow control. Okay, then there is encapsulation. So what is how it is going to be encapsulated? Encapsulation into data frame. It will encapsulate which data is coming from network layer. It will encapsulate each frame contains source and destination MAC address. Suppose that we have a switch and there are few users. Okay, so if they are connected, that in that case, every every data should have mentioned the source MAC address and destination MAC address. Suppose that this MAC address is A and BB. So on the data packet here, this is data, and it will add source and destination MAC address. Okay, and after that it will convert into bits, and it will forward to the layer 1, and layer 1, what is layer 1? That is physical layer. So, and then there is other example of it we are going to use, that is error checking. So it will also happen. One second, why it is not working properly today? Maybe there is some issue. Then there is physical layer. Physical layer, what it will do? It will use like it will convert our bit layer 2 information to layer 1, or it is also using some kind of medium, that is electronic medium, or it could be a optical medium, it could be a radio frequency as well. Okay, so how it is going to be function? Physical layer deals with physical transmission of data over the network medium. It's defined characteristics of the physical connection, such as cable connectors and signaling. Okay, encapsulation, what, how it is going to be encapsulated? From when the data is coming from data link layer 2, it will convert into electrical signal, light or radio waves, radio signal like Wi-Fi, or optical like optical fiber. It will, we are using in the network optical fiber, as well as Ethernet. Here you can see electrical signal, maybe Ethernet cable, by using Ethernet cable as well. Okay, so for transmission over the physical medium. Okay, for example, Ethernet cable, Ethernet electrical signal and frames, they, it will convert into frame. Example, Ethernet cable, fiber optical cable and wireless radio waves. For suppose that if you're using mobile and it is only working on wireless network. Okay. Finally, there is a physical network converts the digital signal into a physical signal suitable for transmission over network medium, over the such as electrical signal, light pulse, or radio waves. Okay, then what is this? What was this? This was just OSI model encapsulation. So what basically what was the encapsulation? Okay, and what is the encapsulation? So first let's discuss about encapsulation. Encapsulation is the process adding header and some tailors of the data. It moved down to the OSI layer when the packet is coming from layer 7 to layer 7 to layer 1. In that case, we are using encapsulation. When data will come, data will go to 7 layer 7 to from layer 1. In that case, it will use encapsulation. Okay. Again, it's happened. It's again started doing such thing. I don't know what's happening with it. I don't know what is happening. Okay, encapsulation is that process. Each layer adds its own header on every time. Just a second, guys. हाँ सब सजाइए तुमने होया तो 1 मिनट okay. Each layer each layer have their headers, its own header. Like layer 7 have its header, layer 5, layer 4, layer 3, layer 2, layer 1. Everywhere in the network there is a header. Okay, we will discuss header in when we are going to basically by using packet capture we can understand very well. So for now we are not capturing because we have to go for simulator or emulator. So because of that reason I'm not using here. So each layer adds its own header information to the data received from the layer above. Suppose that it is coming from 7 layer 5 layer 4. So it will add layer forming a hierarchical structure. Okay, at the receiving end, each layer is stripped off and corresponding headers information before passing the data up to the next layer. Okay, then there is the process of encapsulation and de-encapsulation ensure that data is properly handled and delivered across the network. Because suppose that if there is anything missing in network or anything missing on the data, it will not going to be delivered to the next server or client or requester or sender or receiver wherever it is going to. Okay, what is de-encapsulation? The OSI model is the process of removing de-encapsulation is what it is, process of removing what headers. Suppose that there is a specific protocol which we protocol specific, okay, header, or suppose that HTTP it is some data is coming from HTTP. In that case it will remove HTTP and after that it will show, or it will encapsulate first, it will encapsulate then it will come. Each layer remove its corresponding header and sometime it's called what, tailor. Okay, from the data received from the layer below before before passing up to the next or higher layer. Okay, this process is continuous until the data is reached to the application layer where it is presented to the user or application. If this is the presentation, suppose that I'm using presentation or PPT presentation, it will only happen when the application is sending in application layer is only able to use this data, you read this data because of layer, or hope you understand. Okay, so we will go for a de-encapsulation process in a while. Let me take a 5 minute break. If you have any question, then you can ask. So I'm back. Hope you guys are back. So what was question? Uh, what was your question, Madhusir? Are you there? No, he is not there. If anyone have question related this topic, किसी का कोई क्वेश्चन है? Yes, yes. Let me share. Okay. So the encapsulation is also a process. Suppose when packet is encapsulated, definitely there will be a process for the encapsulation, because here will be removed here from this process. Okay. So how it is going to be removed? So we saw in the last few slides, like encapsulation is a process, how it is going to be add, okay, something either header or tailor. So it is going to be removed. We are going to remove in the encapsulation. So de-encapsulation is a crucial process for the OSI layer, Open System Interconnection Module. Okay, that is particularly on the context of data transmission. It's occur at the receiving end of communication system. How the sender, this is sender, it is coming from layer 7, 6, 5, 4, 3, 2, 1, and this is, there is a receiver. I am not let me write something if there is anything. 1 second, guys. Let me check if there is anything board like that. I don't know how to get the board. Okay, so suppose that it is going from 7 to 1 and 1, 2, 3, 4, 5, 6, and then 7. So this was the process of encapsulation, and this will be the process of de-encapsulation from 7 to 1 and 1 to 7. So we will learn properly here de-encapsulation process. Again, it's doing same thing. Okay. Let me go with that slide. So how it is going to be performed de-encapsulation on, let me enable automation. Control acceptance. Okay, so on physical layer, when the data came from layer 1 to layer, from sender to receiver side, then what it will do, at the receiving end, the physical layer receive a raw signal. Either it could be a wave signal, radio wave, or it will be a electrical signal or optical signal, digital signal calls. Okay, it remove any physical layer specific information and pass the data into the data link layer on layer 2. Okay, then layer 2, what it will do, it will check information about physical layer information like MAC address. So it will check proper MAC address, it is related with that MAC, its on MAC address. If not, then it will discard. If yes, then it will go for up it will check, and it will send that, it will remove that in MAC address, and it will accept first, it will remove the MAC address information, and it will send information to the next layer. Okay, the remaining data packet, that is called, basically here it is called what, payload. You have to remember that thing. Okay, and then there is next thing, it, when the packet will come to the payload, will come to the layer 3, then what it will do, it will check for the IP addresses. IP addresses for what? Because we are doing it is doing de encapsulation. So it will check the packet layer, network layer information, and that will be IP address. If IP address is matching, then it will accept that uh, data, and it will send to the upper layer. Okay, then what it will do, this is payload, it is okay, then what, then it will do, it will forward that data to the layer 4. And layer 4, it will, in how it is going to be encapsulate, layer 4 encapsulate transmissions, it's layer, hello, who is this? Okay, transport layer segment from network layer. Okay, when the, it will receive from transport layer, sorry, data link layer, and then network layer, then it will go to the transport layer. The transport layer receive the transport layer segment from the network layer, and it will remove the transport layer header. Okay, and it will, including source and destination port number. Transport, basically it will based on port number like 80443, http, https, or there is ssh telnet 22, 23, 21 port number. There are many port, 143 or 57, 58, 67, 68, 53. So it will remove that, then it will check for error checking in, and it will check error. Okay, because it is going to use TCP and UDP as well. So remaining payload, it will send to the session layer, layer 5. Then what layer 5 will do, layer 5 will check the session during the transmission. If there was anything missing, if it will check. Okay, so it will remove the layer session, layer 5 session layer information, and then it will inform to the next layer, that that will be layer 6. Okay, then when the data or payload is coming from 5 to layer 6, how the presentation layer will receive data from the session layer, then it will check for what, the data type, what kind of data it has received from sender. So it will check, look, like a specific data, like if we were sending photo, video, any docs file, any excel file, or there are many more types of data. So it will check, it will remove any presentation layer, there is any presentation layer information, it will remove, and it will compress that data for user. Okay, and it will send to the that information to next layer on application layer. And application layer is the, that layer where you can user, you or user can see the information about that, see the information or see that data, or they can use that data. Okay, either it is there will be two type of present application print, either printed media or display media. So it, by using display media, it will see it when the application will layer will receive the information. Okay, it by using protocol http, https, or by using it will receive. Okay, or by using ftp, tftp, and it will show information to the user. So this was the proper info data, and you have received this data from layer sender. It sender has sent this in data, like either it is pdf, either it is document, either it is photos or videos, anything. So it will remove application layer information, that information layer header, that containing application information specific, like it is sent it by any specific application. Okay, So this was the final reach of data. Okay, so this was the summary of OSI layer. You can you can note this information because it is important, as we will discuss in past few, where we will use summary. We will use this information in upcoming videos, because layer, and it will also help you to understand TCP/IP model. Okay. So, and who has question? I don't know. So if not, then we are going for TCP/IP model, because TCP/IP model is what? TCP/IP model is the architecture which is actually used in network. Okay. So let me open TCP/IP and let's go. So TCP/IP is transmission control protocol or internet protocol. So why we are using TCP protocol, how it is going to be work in a network, in computer network, why it is important. So we will learn each and everything here. Like TCP/IP fundamentals encompass the fundamental principle of the transmission control protocol or internet protocol suite. This is the backbone of networking model. Suppose that if you are using any kind of devices, so TCP/IP is only responsible for that. OSI model was the just a reference model. Okay, so TCP/IP include understanding it include understanding of IP addresses or TCP/IP payload layers architecture, compressing at or from application transport. There is some only four or five application, five layer you will see in sometime you will see four layer. So there are few layers, that is application layer, transport layer, internet layer, and link access layer, or we can say that physical access layer as well. Okay, so what is fundamental also cover it when we are going to discuss about it. So it will also cover like routing, switching mechanism. Okay, additionally we will see how it is going to be work in network. In summary, in what we can say, TCP/IP transmission control protocol is the fundamental protocol suite for communication on the internet and the most modern computer network. Everything is working through this. It consists of two main protocols, TCP and IP, transmission control protocol and internet protocol, along with the supporting protocols. Either we can use multiple protocols are there, 65535 protocols are there. So we will learn later. Okay. So transmission, what is transmission protocol? So transmission protocol we are going to understand here. So transmission control protocol, it has something similar like we learn about OSI layer. So there is some kind of function of it. So it will provide reliable communication between source to destination. It is connection oriented communication between devices, establish virtual connection and ensuring that data is delivered without error and its corrected order. Because in on layer 4 we see what we see, TCP, UDP. Okay, transmission control protocol and user datagram protocol. So TCP is reliable and UDP is not unreliable protocol. So because of that, we are using TCP is important in every network. Okay, let me this first. I don't know what is happening whenever I'm using pen. Maybe something is some issue is with pen. So connection, how connection is going to be established between source and destination? There will be three-way handshake process called sync, and acknowledgement. Let me go with paint. Hope it's work, because sometime draw. This is paint, right? So suppose that there is a user, sender, and this is a receiver. Okay. So when the TCP connection will establish, there will be three-way handshake. First, sender, it will ask to user that it will send sync packet. Then what sender receiver will do? It will send sync packet plus acknowledgement. Oh, sorry, request. Here you can see, and then it will send SYN and acknowledgement. Request, it is not a part. Request is a part of DHCP. So SYN and then it will acknowledge. Okay. So suppose that it is asking for IP address. So first it will send sync packet. Okay. So it is trying to, then connection will establish SYN and then acknowledgement. So there are three part which is called three-way handshake. Okay, because the pen is not working properly, so I am using it. Then reliable data transfer. TCP acknowledge every received packet. Suppose that it was started and sender is received packet, or this is sender or this is receiver. When the receiver will receive packet, it will acknowledge for every packet, so that it will ensure receiver has received the packet and it is 100% okay. So, okay, it will always try to use this mechanism, three-way handshake. The flow control. Don't know what is happening. Let me disconnect it. Then there is flow control. Flow control, it is use it's regulate rate of data transmission between sender and receiver to prevent sender from other way the receiving with the data. Okay. Then there is next thing, that is conviction control. TCP detects and responds to the network, where it is. Let me erase. To the network congestion by adjusting transmission rate of avoid packet loss and maintain network stability. Suppose someone was sending, okay, in that between something get missed or network connection is not established between source to destination. In that case, packet is not going to be delivered to the destination or receiver. Okay, so it will maintain that thing also. For example, when you download a file from a server, TCP ensure that file is transmitted reliable. Okay, file is transmitted reliable. Okay, reliably. It's break the file into a packet, send information to your computer, send them to the computer, like by using segmentation. That it will ensure that it is reassemble. Reassemble is correct by using, suppose that we were sending 5 packet HELLO. It will ensure, so packet is assembled correctly or not. For example, HELLO, suppose that HELLO, there is a capital or a small. Suppose if it is encapsulated like HELLO, so it will ensure everything. So it is in sequence or not. Okay, packet. This is the segmentation and this is reassemble. So it will ensure everything. Okay, TCP use protocol like HTTP, HTTPS, and TCP use HTTP, HTTP. Array. One second, guys. Maybe I don't know what is happening with it. One second, guys. Okay. Deassemble erasing ink. Let me open my pen again. Select the thing. Okay. Okay. Then there is next thing, IP protocol. So IP protocol, what is IP protocol? Internet protocol, how it is going to be function, how it is going, what is IP addresses, routing, fragmentation, and okay. So and the thing and so on. So IP address is responsible for addressing and routing packet across the network. Like every user have MAC address, there should be an IP address as well. I already shown you how it is look like. So suppose that there is a user and he or she is sending information to the destination. He is sender or this is receiver. So there should be a MAC address as well as IP address. Okay. So IP address, there should be IP address. So IP protocol is responsible for routing as well, routing across the network. Suppose that this is 192 series and this is 172 series. So this is totally different subnet. So router will use IP addresses to share information between to across network. Either it is its own network or different network. Okay, it's provide the best effort to and connectionless delivery services, because suppose that connection is not getting established properly, in that case what it will do, it will not going to be share information or share data to the receiver or other resources. When packet are forwarded independently and may arrive out of the order, or it could be or be lost. Okay, then there is IP address. What kind of IP addresses is there? One second, wait. I don't know what is happening with it. Maybe something is missing. Something is doing mess with me. I haven't given control to anyone. How it is? Okay, let me restart. If it will not possible, then we will go. We will learn it tomorrow. So let me start it again. So we were on IP address, right? So IP address, every device connected to a TCP IP network, and it's assigned unique IP addresses which identify on the network, its own network. Okay, IP address uniquely identify network devices, like we are using mobile number, and mobile number is used to communicate to you guys. So this is similar look like that. Every device use 32-bit for 32 32-bit address, and it's called IP address. We will discuss in subnetting in a brief how it is going to be look like, how we the what kind of subnet will be there. So IP address is a 32-bit address. Okay, and it is dotted, like example is there, 192.168.0.1. Every dot is for like here you can see this is in four different segment. Okay, so every number 192.168 belongs to 8-bit. This is also for 8-bit address, and including 8 into 4 32, sorry, 8 into 4 32 bit. So this is 32-bit address. When if we are talking, we will learn about IPv6, then it will be 128-bit address. So that is, this is just dotted decimal notion. Okay, and this will be the hexadecimal. IPv4 is decimal, and this is hexadecimal 126, 128-bit. Okay, then there is routing. I Again it is missing us. It is automatically started. Don't know. I think guys there is issue with something, and I'm trying to fix that, but it is not fixing yet. So let's see what we are going to discuss. So I think I am okay with it. If anyone have question related this, or let me go with it and let me discard. Let me open uh, Google PPT. I don't know why it is happening. Let me start it. Just a second, guys. It will take just a minute or two. Mhm. Yes, yes, yes. I'm on it now. Maybe something is creating mess with me today. I don't know why it is. It is lagging too much. Okay, no issue. It is still loading. Let me go that slide. Where TCP IP and TCP and IP. Okay. Okay. So I can't write anything here, and let me check with Epic. So I can't use anything here. Okay. Online to there is any kind of ping. Okay, shift tag. So yeah, here you can see the function. Already we discussed about the function IP addressing schema, like how it is going to be. How we are going to check the IP addresses, we will discuss later. But IP addresses here, we are using IPv4 is a 32-bit address, and every single octet have 8-bit. Okay, so it will look like that. Suppose that if you are going for a CMD, and if you are talking about IP addresses, so how it will look like IP config. This is address, and it is 32-bit address. So it is uh, separated by dot, and because of that it's called dotted decimal notion. Okay, then there is IPv6 as well, and it is 128-bit address, and it is expressed in hexadecimal. Okay. Then what is routing? Routing packet is that which is used in IP protocol, which use IP. Like if we are sharing any information from source or from one network to other network, in that case we are going to use IP or IP. And there is one more thing which we are going to use, that is routing as well. So there are some type of routing, like we will use OSPF. We are using OSPF, BGP, EIGRP, or other IP protocol, or either it is static IP routing as well. So routing protocol is also we are going to use in computer network. And then there is, again it is not working. 1 second. Presentation is not open, right? Okay, let me close it. So how fragmentation and reassembly is working here? So fragmentation and reassembly is working like IP can fragment packets into a smaller unit for transmission across network with the different maximum transmission unit by using with different MTU. It's called MTU, maximum transmission unit. That is maximum transmission unit is 1500. So 1500 bytes packet it will convert by packet by into maximum 1500 bytes, and it will send to the network, so that it will carried by TCP or TCP IP. Okay. At the destination, IP reassembly fragmentation into original packet. Every 1500 MTU packets will reassemble on receiver. Okay. Pen is not working. Like example, if you are using if we are transmitting, 1 second, where is pen? Pen should be erased. So if you are using you are sending a packet, you are transmitting a data between device, it will use local area network or it will use local IP addresses. Okay. TCP is used to protocol like HTTP, SMTP, FTP, TFTP, SSH, telnet, or many more routing protocols. That is reliable. Internet protocol. Okay. So after that, we are going to learn about TCP/IP model. How many layers are there in a TCP/IP? So there are 4 layers of in a TCP/IP. Like we already learned 7 layer of OSI. So it is just convert. There is some kind of merger in TCP/IP model. So there are first layer is application, which is fourth layer, transport, which is third layer, internet, that is layer 3, and network interface layer, that is fourth layer. So it will work similar as OSI layer. Okay. So this is L1. It's also called L1, L2, layer 3, and L4. So here you can see these are 4 layer of application. Application, what is the application layer? The application layer is a topmost layer of the TCP/IP model, as similar as OSI layer. Okay. It is responsible to providing network services directly to the end user and application. It is directly providing services. Either you want to watch the video, or you want to share the packet, you want to work on Excel, so it will directly work on that. It's include protocols such as HTTP, HTTPS, SMTP, DNS, DHCP, and telnet. It is This is similar, such as similar. Okay. There are many more. Suppose that we can use this thing just for now, for example. Okay. Which enable various type of communication and data exchange between application. Like if we are using HTTP, then we can also configure the switches. HTTPS, we can configure or we can validate switches, or we can monitor the network devices. By using FTP, we can take backup, we can take multiple things, we can store or we can copy packet from there. SMTP, we can send email services. DNS, it will help you to resolve uh, domain name. Like if you are using for example, for networking scholar, you will search, then it will help you to resolve the addresses. Then there is DHCP, it will help you to get the IP addresses. And there are telnet, it is also a remote access protocol. So these kind of protocol which is going to be used in in this layer, interface, in this layer interact directly with the end user. Okay, because this is, here you can see, I used what, I used an application that is PPT, which is go on based on Google. Okay, so we use that an application, and it was just an application. By using HTTPS, I am using this application. So okay, and it's provided an interface across. It is providing an interface like how I can write, I can share in, I can move up, down, next or back. I'm just like that. I'm using back navigation button. So it is moving to the next slide or next available option, which is in slide. Like system, this is your system, user system is there, and there are in some interface look like that. Okay, and applications could be like Twitter, YouTube, or Chrome, or I'm using as. So this kind of the thing is in related in application layer. And then we are going for a transport layer. So it provide reliable communication, reliable, it is reliable, okay, to provide data transmission between source to destination. Or, and there is a two part, first is TCP or other is UDP. And this is the thing. Let me 1 second, let me change something else. Pen, enable pressure and sensitivity, done. Okay, and it is still same, no issue. I can't change anything. So TCP and UGP, by using TCP and UDP, you will already learn about it in a OSI model. The transport layer protocol is responsible to end-to-end communication between devices, ensure that reliable and orderly delivery of data. It, it is similar, which is similar live. If sender is sending something, so receivers must receive all the packets. If not, then it will discard it. Okay, till reassembly. It's included protocols such as TCP, transmission control protocol, and UDP protocol, user datagram protocol. User datagram protocol is less erase all. It's connection less and connection oriented. So TCP is connection oriented communication, and okay, it's established virtual connection between sender and receiver. It is making a connection like a building. It will build a tunnel look like that. And receive segment, receiver, sender, between sender and receiver, segment data into a smaller packet, similar as we all learn in OSI model, numbering them in reassembling and ensuring delivery and error recovery as well. Suppose that something was missing in hello, then it will check for that and it will recover. UDP is unreliable and connectionless communication. Let me erase it so that you will see properly and you will make a note if needed. Okay, and it is used for application where the speed and efficiency are prioritized over reliability. Suppose that you have to send, you are using walkie talkie. In that case, we are using UDP. Okay, this is unreliable and connectionless. Suppose that someone is throwing a ball, and for to A, and A is not going to catch that ball basically, for example. So it is just, it will so just it will throw the packet in the network. It is not responsible to deliver that packet in the particular destination, particular receiver. In that case, like if you are using real time string protocol, either this is Zoom, this is also a UDP, it was UDP, but here you can see this is a TCP based. Or like video calling, if you are using WhatsApp and video, we can say that video or calling, something look like that, and gaming as well. Okay, let me erase, every time I have to go with it. So here you can see this is This is just sending information packet. It is not responsible. Suppose that if there is anything, it will not prompt anything. Okay. Then there is transport layer protocol. Internet layer protocol. What is internet layer protocol? It's handle packet addressing and routing using IP. Suppose that something is coming from one address to different address, and it is sending from source to destination. How I can more option? 1 second. Print keyboard shortcut. Yeah, I can't do anything. I'm just using color. So the internet layer is also known as network layer. Okay, it is responsible for addressing, routing, and forwarding data packets between devices across different network. Suppose that there is a router. This is a subnet for 192.168.1.0/24, and there is 172.16.0.0/24, and there are 100 user, and similarly 100 users are here. It is a when suppose one of the user, this is sender and this is receiver. In that case, what will happen? Sender will send in packet by using this is different network. Okay, suppose that there is a switch between the host and there is one more user, and its IP address is 1.11 and its IP address is 1.12. Suppose it is sending information to its own network, then there is not required for routing or anything. Just there is responsible, what is that? That is addressing. If it is going beyond its network, then there is required what? Routing. So it will, when the packet will go to the router will check the routing and its interface, connected interface, and it will send packet to the destination network, and communication will happen. Okay, it is all. It's included IP protocols such as different schema is there. Like we will use class A, class B, class C IP addresses. It's say someone is saying something. Okay. Okay. IP address is unique address to the devices and routes packet based on at destination IP addresses. We already discussed multiple times. It's enable communication across interconnected network because every user is using one IP address. Okay. Either it is IPv4 or version 6, IPv6. Because of PPT, I can't write anything good. Not good. It is not good for me now. Other protocol is the layer included ICMP, which is used for error reporting and network management, and IGMP, Internet Group Management Protocol, which is used for managing multicast group membership. So suppose that there is a anycast or multicast, we will discuss in IP addresses part. Okay, so that will help you. That will help you to understand. So how the internet layer is going to be work. Okay, then here you can see this is a router and this is a one segment. Okay, there are multiple destination. This is sender. It is sending a packet. It's came to the router, and this is different subnet. So router, what it will check? It is not sending here. Okay, so it is not sending information to this packet. Just sorry, to this user. It is only sending info packet by using IP address, by checking the destination IP address to directly this address. Okay, so providing routing assistance during transmission. Here you can see because of, and there is layer 1 that is called network internet interface layer. So network interface layer is similar as a layer 1 and layer 2 of OSI model, combination of layer 2 and layer 1. So transmission data packet over the physical network, and it's deal with hardware specific addressing and protocol. Hardware specific addressing in the sense MAC address and protocols. Okay, so it will work on that. Suppose that the link layer is also known as network interface layer or data link layer. It is responsible to transmit data packets between devices within the same network. How? Same network. Suppose that this is switch and we have configured a VLAN. 10, and there are two PC that is connected to each other. Okay, and let us connect 4. So 1, 2, 3, 4 PC are there, and they are connected in a single VLAN. Whatever IP is there, but just it should be a single subnet. So it will check, just it will what it will check, it will check MAC address of the source and destination, and it will send information, or it will send the data to the destination by using MAC address. Okay, or layer 2 information. What is layer 2 information? That is MAC address. So it will just only check that. Let me erase every time. Shift A is for erase, including it includes protocols and standards that define physical and logical connection between devices such as Ethernet, Wi-Fi 802.11, PPP point-to-point protocol, and ATM, auto synchronized transfer module. ATM basically it is not for use. We are not going to use in these days, but we are going to use P2P, Ethernet, or Wi-Fi. So it will work like in the OSI model. What was there? Like there was Ethernet, optical, and wireless radio. So this is the thing. Okay, in this layer, encapsulation of IP packet frame should okay, it will encapsulate packet, and it will transmission over the physical network medium by using these thing, Ethernet, Wi-Fi, or P2P, as well as there are many. These are the three things which we are going to use. Okay, it will this is just a work as a medium. Here you can see the packet is here. This is a file. It's converted into a digital signal. Digital signal come. You suppose that you have connected your laptop or machine by using Wi-Fi. Okay, this is also a Wi-Fi machine. So the packet converted into bits. Bits sent it to the router, and router what it will check. It is connected through Wi-Fi. Okay, here you can see the Wi-Fi signal. So Wi-Fi, and this is also this PC is also connected through Wi-Fi. Shift A. Okay, so how it is transmitting the packet, it is sending the same thing, the binary, the bits, and it will convert into by using this its MAC address or by Wi-Fi card, it will convert into frame. Okay, so how it is going to be work here? So protocol and services of type TCP IP protocol. Maybe there are many interfaces. So I think we are at endpoint. We have only 2 slides, rest of 2 slides available here. So protocol and services support by TCP IP. What kind of protocol it is going to be support on TCP IP? So TCP IP use a wide range of support protocol. So how many protocol we have? One second. So we have 65535 protocol. One second, guys. Let me close it. And okay, and let me write again. Okay, it is not working properly. For now, today we have to work only like that. Shift A. Shift A is also not working. So suppose that there is a DNS. Okay, so services, TCP IP protocol and services. So DNS, what it will do? It will change human readable name into IP address. Like domain name we are using. Suppose that if you are checking the networkingscholar.com, it will convert into IP address. How it is going to work? Let me show you. Suppose that I am pinging networkingscholar.com. It will convert. Here you can see the domain name is converted into a IP address. Okay, so it's work like that. DNS. After that, there is one more protocol we will use, that is DHCP. So how DHCP is going to work here? Okay, let me share you. So here you can see DHCP. So how I am going IP address. So this is first, my address is 2.37. Okay, this is not preferable. So let me open ncpa.cpl. Hope it is visible here. It is opening here. Okay, so this is my home network, and if you are going to check the status, you will see internet protocol and everything, like DHCP enabled. Yes, so this is used by TCP IP protocol. Okay, here you can see the IP address 2.37, which is matching, right? Which is matching, as well as the DA 2.37. What is default gateway? Because of IPv6, it is also enabled. Because of that, it is showing leak local address. And what is 192.168 is my gateway, right? DNS server is also same admin server, because I have configured something different. Here you can see the IP address and gateway as well. IPv6 address. This is address 19, and this is the gateway of my IPv6. Okay, if you want to change, then you can go here in the property section, and you can uncheck the IPv6. Okay, and show you again. Here you can see I am not able to see IPv6 address. Okay, so this is the thing which going to use. We are going to check in our DHCP server. So what DHCP server is doing? DHCP server is just allowing giving the IP address to the client by using DHCP port number 66 or 67. One second, right? Okay. Then there is SMTP. It is used to send email, SMS, email. Okay, basically for simple mail transfer protocol, we are saying that. Then there is FTP. FTP is used to share sim file, send the FTP to share the files. Like if you have stored something on FTP server or file server, then we are going to use FTP protocol. Then there is HTTP. HTTP is used to share hypertext transfer protocol, that is used for basically web related thing, like website or something we are surfing on internet. Either it is whatever it is in the network, so we can use SSH. SSH is providing secure remote access between network devices. Like if we will configure router, switches, or any kind of firewall, in that case we will use SSH, secure socket layer. Okay, and then there is ARP. ARP is responsible for address resolution. Suppose that if someone is trying to send trying to check the trying to get an IP address, or it is asking for IP address, then address resolution protocol ARP we will use to uh, get the IP address from DHCP server, or the by using MAC address as well. Okay, so ARP maps IP address to MAC address into a local network. We will learn on switching how ARP is going to be work. It resolve IP address to the correspondence MAC address. Okay, MAC address to enable communication between device within a same subnet. So ARP is only responsible when we are going to say we are going to for a same subnet, same if we are in same network. Okay. Then ICMP we already discussed. So ICMP is a messaging protocol that's enabled to that's provide us to check the connection between source to destination. It is also helping us to, like if we are going for a ping, we are pushing a ping information, then ping we are initiating. Let me initiate so you will understand. Suppose that I ping na last time I did ping networking scholar. So ICMP is working here to check the connection between destination address. Okay, and there this is how TCP IP model came into the network. If we have OSI model, then why there is TCP IP? Hope you understand about it. So there are seven layer. Upper three layer, it's converted into application layer. This is also called upper layer. Okay, transport layer is same on the layer 3 transport layer. Okay, layer 4 network layer converted into the network layer. In OSI it was on layer 3 and here it is on layer 2. Data link and physical layer converted into network access layer. So this is the 4 layer of TCP/IP model which is adopted in modern network. So when we are going to use, if we are going for a theoretical, you are going to use theoretical knowledge, then in that case you have to learn OSI model in deeply. If you are going to use just you have uh, to check the IP addresses or you are going to configure devices, in that case you have to work for TCP/IP. Thank you for watching this video, because this was the last slide of for today, and hope you guys understand. If you have any question, just you can let us know, so that if you are watching on YouTube, just you can check the YouTube link, as well as you can scan the QR code from your mobile phone and you can join us. So basically we are available on website as well as LinkedIn, YouTube, and you can also contact us on by using contact us WhatsApp number is there. If you will click over there and you will reach WhatsApp basically. Okay, so I'm going to stop WhatsApp. I'm going to stop live on YouTube. Thank you for watching this video, guys. And I'm just stopping live streaming on YouTube. Okay, guys. So we are stopped. And Rahul, what is DHCP? DHCP is what? Basically, it is providing dynamic host control. It is called dynamic host control protocol, configuration protocol. Okay. So what it will do? It will suppose that if you are trying to go, or if you want IP address, okay, and you don't know what kind of IP address is going to config, what kind of IP address you are going to use in your laptop. Suppose that or if there are multiple user are there. Let me stop my streaming as well, and streaming, and yet